Oh, here we go. Working. So Mr. Hale here. Miss Scott is also here.
Hey!
And today we're talking about linear inequalities in two variables. So we're thinking about how we graphed equations in two variables, so lines. And we are then going to now do linear inequalities. So this first little do now says tell whether the ordered pairs below are a solution to the inequality. So we have this little inequality here. And we first want to start with letter A. It wants to know if 0, 0 is a solution. So the first 0 is the x value, the second 0 is the y value, and I'm going to replace x and y with 0 in the inequality. And now negative 0 plus 2 times 0 is 0, less than 8. And you have to decide, is 0 less than 8? And the answer to that is yes. So therefore, 0, 0 would be an ordered pair that would solve this inequality. So if you look at the next one, 0, 4. So again, negative 0 plus 2 times 0 is less than 8. I made a mistake there. It's 2 times 4. So we got x is 0, y is 4. So negative 0 plus 2 times 4. So we get 2 times 4 is 8 is less than 8, and 8 is not less than 8. So this one is no. So the 0.04 would not be a solution to this inequality. So what we're seeing is that these inequalities have many, many different solutions and then many, many different points that are not solutions. And what we're going to try to do is separate the solutions from the non-solutions. So let's look at C real quick. If we plug in 3 for x, we get negative 3 plus 2 times 5 is less than 8. And then I get negative 3 plus 10 is less than 8. And I get 7 is less than 8. And then we know 7 is less than 8. So this one would be yes. So here, A and C would be solutions, and B would not. So the whole point is we could go on and on and on with this with an infinite number of points and have a bunch of points that work and a bunch of points that don't. So what we need is a quicker way. So some vocabulary, we have something called a boundary line. This boundary line is going to divide the coordinate plane into two. One is going to be all the good solutions and one is going to be all the bad solutions. So the good solutions are the ones that work, like A and C, and the bad is going to be the ones that don't work, like letter B from the do now. A test point, we're going to have to use just 1 point. We're not going to have to test 3 like we did in the do now. We're only going to have to test 1 point. That point is going to tell us which side of the boundary line to shade, which is our last vocabulary, shaded half plane. So we're going to make a boundary line. We're going to cut the coordinate plane in half. We're going to test a point. Then we're going to shade the side that represents all the points that work. So let's take a look at an example. So step 1. Graph the boundary line. So the boundary line is going to be a line. So this is going to be an equation. So I'm going to graph the line y equals 4x minus 3. So I'm going to replace the inequality with an equal sign. Now we should remember this. This is a y-intercept of negative 3. We've been doing this for a while, pretty much all year long. And the slope is 4, so I'm going to go, that as a fraction is 4 over 1, so I'm going to count up 1, 2, 3, 4, and I'm going to go right 1. And then when I graph the line, we want to remember when we graph inequalities with one variable, we use an open circle and a closed circle. Now what we're going to do is use a dashed line or a solid line. So if it's exclusive, we're going to use a dashed line. And if it's inclusive, we're going to use a solid line. So if we look at the inequality, that is clearly exclusive. So we are going to draw a line that is a solid line. Sorry, a dashed line. So what this does is we have a left side and a right side. And we're going to split it up, and one of these sides is going to contain all of our solutions. So the second thing we're going to do is test a point that's not on the boundary line by checking whether the ordered pair is a solution. Personally, I think the easiest point to pick is the origin, because when you plug in 0, 0, it's very easy calculations. So what happens here is we can pick 0, 0 because the key to this is test a point on the boundary line by checking whether, test a point not on the boundary line, sorry. So the key is that it's not on the boundary line. We can see that the origin is not on my boundary line, so I'm going to test that. The origin is 0, 0, so I'm going to replace 0 for y, and I'm going to do 4 times 0 minus 3. If I evaluate this, I get 0 is greater than negative 3. What this is a true statement. So this 0, 0 is a solution. And my last step is to shade the correct half plane based on the result in number 2. So what happens here is I have two options. I can either shade on the left side of the line or on the right side of the line. And what happens is, since the test point that I used was correct, I'm going to shade on that side. So the answer looks like this. So you're going to shade this whole side. And your answer is the shading. This is what's different. You're not getting like x equals 7 or something like that as an answer. The answer is the shading. So looking at this graph, this is an entire answer. It's every point. So no matter what point I pick, if I pick a point here, I pick a point here, I pick a point here, I pick a point over here, every one of these points will work. They will solve this inequality. If I pick any points on the other side, say here or here or here, those points would not work. So that's why I do not shade on that side. But there's no need to test more than one point. The point either works or it does not work. So let's try another one of these. So step 1, I'm going to write x plus 2y is less than or equal to 0. Now notice that this one is in standard form. And I actually am supposed to change it to an equation. So to graph the boundary line, I'm going to make it an equation. So what I need to do when it's in standard form is I need to find the x and the y-intercepts. This is not a test point yet, so don't think that we're doing any kind of test point.
Hey, Scott?
Yeah.
If you get a chance, I have an ASA form for you.
Okay.
All right, and we're back after the interruption from Miss Block.
Sorry, I'm so sorry. Sorry, guys.
So, all right, so again, we're finding the x and y intercept. Right now we're on step 1, which is just graphing the boundary line. Graphing the boundary line is replacing the inequality with an equation. So if I plug in 0 for x, I'm going to get 2y equals 0. And I'm going to get 0 for y. If I plug in 0 for y, I'm going to get x equals 0. Well, this doesn't really help me because this gives me 2 of the same point. So what I need to do is this. I need to move the 2y to the other side. So if that ever happens, you just move the 2y, or whatever the y is, to the other side. And then I'm going to have to divide by -2. Because you need to figure out what the slope is. So you need to get y by itself. And we have an x here. So what we need to do here is plot the point 0, 0, because that's going to be our x-intercept. So if we were lucky enough to have two different x and y intercepts, then we would have easily just been able to plot our line. In this case, the x and y intercept were both the same. So we have to use this slope -1/2. So we're going to count down 1, right 2. So that's our line. And our line this time is inclusive, so we're going to draw a solid line. So again, this is inclusive, which means we draw a solid line. All right, step 2. is to pick a test point. Well, notice this one goes through the origin, so we cannot pick the origin as our test point. I'm just going to pick another point. I'm going to pick 1, 0. So I'm going to go back to the original to plug in my test point. So instead of x, I'm going to write 1. Instead of y, I'm going to write 0. And I get 1 is less than or equal to 0. Well, 1 is not less than or equal to 0, so I'm going to do a false statement. So that means where I picked my test point to be, that side is wrong. So I'm going to shade the other side. That's your answer. All right, so if you're having trouble, let's try maybe 1 or 2 more of these. All right, so this one looks a little tricky. So step 1 is to just replace the inequality sign with an equal sign. All right, and now we can't do this until it's solved for y. So we want it in slope-intercept form, which is y equals mx plus b. So we want to isolate y. So a couple steps. I distribute first. Now I can add 12 to each side. So I get x plus 8 equals negative 2y. And I'm going to divide everything by negative 2. So I get negative 1/2 x minus 4 equals y. So this is now in slope-intercept form. And the y-intercept is negative 4. So I'm going to plot that point. And the slope is negative 1/2, so I'm going to go down 1, right 2 from this point. And then I'm going to plot that line, and that line is going to be solid because this is an inclusive symbol, less than or equal to. So step 1, graph the line. Step 2 is to pick a test point. This line does not go through the origin, so the origin would be a good test point. So again, the logic behind this is this. If this test point turns out to be true, then I'm going to shade on the side of the line that the test point lies. If it's false, I'm going to shade on the other side. So right now I only have 2 options. I'm going to shade above this green line or below this green line. So let's figure out which one. We're going to go back. You always go back to the original and plug in your test point. So I'm going to do 0 minus 4 is less than or equal to negative 2 times 0 plus 6. So let's figure out what this is. 0 minus 4 is negative 4. 0 plus 6 is 6. 6 times negative 2 is negative 12. So it's saying negative 4 is less than or equal to negative 12. That is false. Negative 4 is a larger number than negative 12. So since this is false, the test point I picked is in the wrong region. So the correct region is the opposite side of the test point. And the shading just means that you're telling us that every single point in that region works, and every single point in the region that you did not shade does not work. All right, so 2 more. These ones should be easier, but they're always called special cases because they're horizontal or vertical lines. But in reality, they should be much easier. We are just going to first graph the line y equals negative 3. The 3 steps don't change. Step 1, graph the line. Notice that this is inclusive. So it is a solid line. And y equals negative 3 is a line that goes through the y-axis, so that is going to be a horizontal line through negative 3. And again, it's a solid line as opposed to a dotted line. Now, 2, our test point. I'm going to pick the test point 0, 0 again. So you can pick any test point you want, but I'm always going to choose 0, 0 if possible. Here I have this is x and this is y. The x, there is no x to plug in, so I don't worry about it. I'm going to plug in 0 for y, and I get 0 is greater than or equal to negative 3. I would say that is a true statement. 0 is larger than all negative numbers. So therefore, the test point that I picked is true. So it's in the good region. So I'm going to shade the entire side of the line that includes the test point. And that is it. So let's try one more of these. The next slide is a duplicate, so you can just skip that. The last one. Step 1, we're going to graph the line x equals -1. That is a line going through the x-axis, so therefore it has to be a vertical line. This one, notice, is exclusive. An exclusive line is supposed to be dashed. We still need the line there as a boundary, but we're going to make it dashed to say that don't include the line, but everything on one side of the line. So I want to put a dashed line. Don't forget the arrows. At x equals -1. Now, again, we could pick the boundary line, or sorry, the test point to be 0, 0. We can do that whenever the boundary line doesn't go through the origin. So 0, 0. Notice this time, I can't plug in 0 for y, but I can plug in 0 for x. 0 is less than -1. So that is false. 0 is not less than -1. So the point that I picked to be my test point was wrong, so I need to shade on the other side of that point. So you just want to think of it, you have a 50-50 chance. If it's correct, you shade on the side that you picked. If it's false, you shade on the opposite side. All right, so that's pretty much it for today. Anything to add, Miss Scott?
Mr. Hill, you just are so perfect and wonderful. I mean, I can't even say one thing better than the way that you said it.
All right. Well, thank you for that. So, all right, so make sure that we come to class ready to solve some more of these linear inequalities, and also next class we'll be finishing the absolute value. So make sure you're understanding absolute value and linear inequalities, because next week, before spring break, we'll be having a test on both. All right, have a good night.